Hello everyone. In this video I'm going to be going over 8.1 and 8.2. We're going to look at the connection between powers and roots. So we'll also talk about what a root is conceptually, but there's going to be a good amount of formulas in these next few sections, at least ways of rewriting things based on formulas. So this is our first one here. It says if you have some number a raised to the 1 over n power, where n is greater than or equal to 2, then you can either think of that as a power, or you can think of that as the nth root, right? And whatever n was over here, that's the same n that's right here. So just to do one in particular, if this is our a is 25 and we're raising this to the 1/2 power, this would be the same as what we really call is the square root of 25. Right, so this 1 over n becomes the nth root. It's typical when 2 is our index. I just used a new word maybe. So this is called the index of the root. Then we usually don't write it. So this would be the same. Actually, without writing it, it's assumed to be a 2. And perhaps now you can plug this in. So the square root is right here. So press the square root, 25. It says it's 5. So why is that? Just a quick explanation. The square root of 25 is 5 because 5 times 5 is 25. So this is just a check here. All right, so the answer is 5. You could have also just plugged this in how it was, right? I could plug this in how it was. So 25 raised to the 1/2 should be the same number. What about a different type of power? Now we have -8 raised to the 1/3. So just to follow this up here, if we have a is now -8 and it's raised to the 1/3, so that means that that 3 is going to become the type of the root. So this would be equal to the cube root of -8. And maybe I'll type that in just to see if my calculator knows what that is. So the cube root is actually behind the square root. So I'll go shift and then square root. Looks like I need to press that better. Shift, square root, and see how a cube root pops up. So that shift, square root actually creates a cube root, and then type in a -8. So it says -2. So this is -2. And this is -2 because -2 times -2 times -2 equals -8. And that's what a root means. And I'll talk more about that in a little bit, but we would have just -2. So you want to be able to go either direction with that. So what we were just doing was going from left to right. So we were just going this way across the equal sign, but you can also go the other way, right? You can start here and then rewrite things as powers if you want, which sometimes is beneficial. So it said if you have a to the 1 over n, that's the same as the nth root of a. So if I have the fourth root of 5xy, this would be the same as 5xy, all under this 1/4 power. Since the entirety of 5xy is inside of the root, the entirety of 5xy needs to be under the power in the parentheses. This is not equal to just 5xy to the 1/4 in general. Okay, so this would be incorrect because it wasn't just the y that was under the fourth root, it's the entirety of 5xy. So these parentheses are necessary. Okay, so what we've seen so far is what we do with this type of power, right, a 1 over n. At the bottom of page 73, we're just kicking it up one slight notch. So just to zoom in on this thing, it says a to the m over n. So rather than just working with a to the 1 over n, what if it was a more complex power like m over n? So this tells us what to do with that. So still, the n is the type of root, right? So the denominator of the power transfers and becomes the index of the root, the type of root. The numerator of the power becomes the power after the nth root is applied. That's one option. Another option, which is actually totally the same, is you can have this nth root still. And then you can actually, if you prefer, you can bring this m power, the one that's in the numerator of the fractional power, inside of the root. And I'm sorry if that's hard to see, I'll write this here. So a to the m over n is equal to either the nth root of a and then raising that to the mth power, which is also equal to the nth root of a to that power. So I'm just reiterating what's being said here. So you have options. So this thing would be equal to, well, it'll be a cube root, right? That 3 becomes the type of root, and then it'll be 8 to the 4th, or I don't have to write both. I could think of this as the cube root of 8, and then after I do that, I can raise to the 4th. Both of these would be the same, and that's what's written here. For me at the moment, I can do it easy this way actually, because I know the cube root of 8 is 2. So I would just need to take 2 to the 4th. 2 to the 4th is 16. Right, if you want though, don't hesitate to just use your calculator. So I could say 8 and then raised to, so this button, and I could just type it in as it was, right? Raised to the 4/3. Rewrite with rational exponents. So I'm going to page 74. So just like we can go from a to the m over n to the nth root of a to the m, we can go this way, right? So again, it's bidirectional. So we're just going left to right, but it's also true to go right to left. So this one, we would have 2xy inside of parentheses. And it was a fifth root, so that's the type of power as far as the denominator goes, and then the 7 goes up top. Right, so that 5 is the denominator, that 7 is the numerator of the power. So what about negatives? So that's one type that we haven't talked about yet. So what this is saying is if you have a to the n, negative m over n, then that's actually the same as 1 over a to the positive n over n. So if I have 100 to the negative 1/2, this would be the same as 1 over 100 to the positive 1/2. The square root can be written, right? We have a 1/2 power, so I can write that as a square root of 100. For square roots, we typically don't write that 2, so this would be the same. And I know the square root of 100 is 10 because 10 times 10 is 100. So I can write 1/10. Don't let me stop you from using your calculator as usual. So 100, the power is right here, and then the fraction. So negative 1/2, it equals 1/10. Eight to the negative 1/3, we have 1 over 8 to the positive 1/3. That would be the same as 1 over the cube root of 8. The cube root of 8 means we're looking for a number, so let me write this down if you're having trouble with that. So just imagine we're unsure of what this is. The definition of any root, in this case we have a cube root of 8, so what we're trying to do, sorry about that, what we're trying to do for that is we're looking for a number times itself 3 times, right? So whatever number this is equivalent to will be the number such that multiplied by itself 3 times, based on that 3, equals 8. This is the kind of puzzle we're looking for when we're presented with something like this. So for that reason, question mark equals 2, right? 2 times 2 is 4, times another 2 gives us 8. So I know the cube root of 8 is 2. In other words, this is 1/2. So 8 raised, again, is this button. Fraction, and then negative 1/3. There's that 1/2. So yeah, on page 76, there's a bunch of these power properties. You're going to want to get to know these, all 5 of them. Okay, so this first one says if you have the same base and those are raised to powers, that you actually add the powers. So for example, if you have 2 times 2 squared, that would be the same as 2 cubed. Number 2 is similar. If you have b to the m divided by b to the n, then you're actually subtracting. So if we had 2 cubed over 2, then that would be the same as 2 to the 3 minus 1, or 2 squared. b to the m to the n, if you have 2 cubed to the 4th, then if you have powers to powers, what this is saying is you actually multiply those powers. So this would be 2 to the 3 times 4, in other words, 2 to the 12, and so on. So we're going to get practice working with these, and you do want to just get enough practice to where you just ultimately know these. So example 6, we have 50x to the 1/3 over 10x to the 4/3. So it says simplify. So 10 goes into 50 5 times. So I can simplify that. And then I have x to the 1/3 over x to the 4/3. That's reminding me of number 2 up here. In this case, we have x instead of b. So what this is suggesting is I can just take 1x and go to the 1/3 minus 4/3. And so I'm applying the second property, right? The upper power minus the lower. So here's the upper power minus the lower. So negative 3/3, right? We'd have 5x to the negative 3/3. Right, 1/3 minus 4/3 gives us negative 3/3, and that would be equal to 5x to the negative 1. And from the property on the previous page, on page 75, the negative power can be rewritten in the denominator as a positive power. And with a power of positive 1, we usually don't write that 1. So I would just leave this as 5 over x. The calculator can't do this one, by the way, because it's algebraic, right? This calculator is great at arithmetic, but it's not going to be able to help us simplify this. All right, 77, you'll see that I pick it up on page 78 in a separate video. Okay, so I'll just do a couple more. This is page 77. And just a couple more simplify cases. So I'll go to part 2 actually. So we have a cube root. That means this entire thing, 8a to the 12th, needs to be raised to the 1/3 power. One of our properties on the other page said if you have a product raised to the nth power, that every member of that product takes on that power. Okay, so for number 4 there, I see that everybody in here needs to take on this power. And not only that, when they take the power on, it comes in through multiply. So I'm going to take 8 to the 1 times 1/3. and then a to the 12th times 1/3. So I get, well, let me write 8 first. So I just get 8 to the 1/3 times 12 times 1/3 is 4, so I'd have a to the 4th. I know the 1/3 power can be written as the cube root. And I know that the cube root of 8 is 2, because 2 times 2 times 2 is 8. So that's basically what a root means, is if you have some nth root of a number, you're looking for a number that multiplies that n times to produce this number here. Okay, so just to summarize, if you have the nth root of x equals some number y, and that means y times dot 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 y n times so n multiplications. This would mean you multiply up to x. Right, so this n tells us how many times to multiply. This x is actually called the radicand, and that's what we're trying to multiply to. And this n is called the index, and that's how many times we multiply. Right, so in particular, here I have the cube root of 8. If that's some number, right, maybe you're thinking about it. Let's just say it equals y. Like you don't know what it is yet. Y times y times y would need to equal 8. Right, so that 3 means we're multiplying 3 times, and we're multiplying to try to get 8. So this implies that this should be a 2. So I can simplify this piece. We should just have 2a to the 4th. That's the exact same as this thing. Okay, maybe one more. Part 4, we have the square root divided by the cube root of x. Okay, so the square root of x can be thought of x to the 1/2 power, right? This index gets transferred over here as the denominator of the power. And then this cube root of x can be thought of as x to the 1/3. One of your power rules, I'm calling them, they're really exponent rules here on page 76. So one of these is helpful at this point. When you have the same base, two powers, we can subtract the upper minus the lower. So based on, I think it's number, well, let's see, number 2. It's this one again. Same base, power, we take the upper minus the lower. So I'll have x to the 1/2 minus 1/3. Feel free to use the calculator to help you out on these little intermediate steps. So I'm just trying to figure out what that resulting power is. So I can go fraction 1/2 minus 1/3. It equals, I get a 1/6. So you could leave this as x to the 1/6. Or you can leave that as the 6th root of x. Right, same thing. All right, talk to you all next time. Bye-bye.